Okay, hopefully you've had a go at building a model here. I'm going to do the same, and then we can see how we compared. Okay, so under tasks, I'm going to go to linear models and binary logistic regression. I didn't change the data set, so it's still the church data. Response variable is churn, and we're trying to predict whether people will churn, so our event of interest is 1 here. Classification variables, so let's see. We're pretty sure that area code was useless, but let's put that in just so that we can see what happens when we put in a useless variable. But international plan and voicemail plan, we saw that both of those look like they might actually be quite useful, so let's definitely include those. How about under continuous variables? Well, maybe we'll just put everything in and see what happens. Okay, so there's all of our variables. We've put all of them in. Under model, main effects model means that we're just going to include all of these without any polynomial terms, any interaction terms, nothing like that. And let's hit run and see what we get. So this is probably going to take a little bit of time. We've got, what, 3,000 odd observations and about 20 variables. So this is probably the biggest model that we've run in class before, so it's perhaps not a surprise that it's going to take a little bit of time. And here we go. What have we got as our output? So we can look at our type 3 analysis of effects to see if any of these variables are useful, though we don't have anything for the different minutes and calls and charge down here, though I'll come back to why we've got a problem there in a second. Looking at our type 3 analysis of effects, I guess before that we should look at our model overall. Is it significant? Yes, no worries there. So now in the analysis of effects, this is telling us which of our variables seems to actually be useful. Area code, not useful. Now, p-value is bigger than 0.05, so area code's not useful, which we had already seen when we looked at the graphs of the data. International plan looks significant, voicemail plan looks significant. Account length does not look significant. Voicemail messages, yeah, it's close to significant, so we'll keep that around for now. Customer service calls, very definitely significant. But now what's going on with all of these minutes, calls, and charge variables? Well, we've got a little problem here. The little problem is one of collinearity. The total minutes, calls, and charge was actually created by adding up the day, evening, night, and international minutes, call, and charge. So what that means is we can't have all of those as individual variables and have those totals in there. Okay, so let's drop out the total for now and then come back to that perhaps later. Okay, so back here, select those totals, delete those, and run our model again. And it took a lot less time. Okay, so now we've got all of the effects analyses here. And is anything significant among those? Looks like no, except for international calls, which we really hadn't identified as something that ought to be significant. So we've got a whole bunch of variables that don't look significant here. Okay, let's try it with the totals instead. Okay, so over here on continuous variables, we'll kill all of the non-totals and add the totals back in, see if that gives us anything useful. And run. Total minutes, not useful. Total calls, not useful. Total charge, useful. Okay, so it looks like the number of minutes we're using doesn't seem to matter, but the amount we're being charged matters. Which I think to me makes some sense, right? I don't really care about how many minutes I'm using my cell phone, but I do care about how much I'm being charged for it. We did see, though, that international calls was significant while total calls is not. Okay, so maybe let's drop out total minutes, total calls, and add in international calls. As we saw, that was significant. We'll run again. Let's see, and I never did drop out area code and account length, so let's get rid of those. Area code, go away. Account length, go away. And run our model again. Do we have all of our variables looking significant now? Seems to be a little unpredictable how long these models take to run, huh? Oh, shouldn't be too much longer. Here we go. Okay, everything looking significant now. Well, got our model overall is significant, good. We've got voicemail messages, which is close to significant. Let's have a look at its parameter, see if it makes sense. So here's our parameters now that we'll be looking at. So let's look at them one by one. International plan, no, has a negative parameter estimate. So this is saying if we have an international plan, we're more likely to churn, which is what we'd already seen looking at the plots of the data, so at least that's confirmed. Similarly for voicemail plan, if we don't have a voicemail plan, we're more likely to churn. And that gave rise to our idea that maybe we could give away these voicemail plans in order to make our customers less likely to leave our service. Number of voicemail messages, now this is saying what? More voicemail messages makes us more likely to leave. I can't make any sense of that. So I think I'm inclined to remove that from our model, but it's not super important probably what we're going to do with that. It's probably just not a very important variable. We've got customer service calls, very significant. Total charge, very significant. International calls, very significant. The more international calls we make, the less likely we are to leave. Interesting. Okay, maybe we should interpret some of these. Customer service calls has a parameter estimate of 0.5078. So we could divide that by 4, and that would tell us for each 1 unit increase in the number of customer service calls, how does that change how likely we are to leave? And particularly for somebody who's on the fence between leaving and not, for somebody who's got a predicted chance of leaving of about 50%. Okay, so divide that by 4, we get about, 12.12, 0.13, so call it 0.13, a 13% extra chance of leaving for every extra customer service call. Alright, what about total charge? Divide that by 4, we get, let's see, 0.08 divided by 4 is 0.02. This is for every extra 1 unit of total charge, for every extra $1 our bill goes up, our chance of leaving increases by about 2%. Okay, so that's kind of interesting there. Yeah, that looks like a good place to stop that video, and we'll move on to analysing our model as a whole next.